There is a man in Holmes County, Ohio, who has not hired a contractor in 43 years. His name is not on any building permit. It never has been. The structures he has built, barns, houses, granaries, a schoolhouse, do not appear in any county construction database because they were never submitted to one. They were built the way his grandfather built them, and his grandfather's father before that, using a system so efficient and so complete that the modern construction industry, which charges an average of $45 per square foot for basic barn construction, has never found a reason to acknowledge it exists. He is standing in a field at 5 in the morning. The field is in the eastern part of Holmes County, where the land rolls in long, shallow waves, and the soil is dark and heavy with clay. The grass is still wet. His boots are already dark to the ankle. Behind him, on a cleared and leveled patch of ground approximately 60 feet by 40 feet, there is nothing. A foundation sill, timber-framed, laid 3 days ago. By this time tomorrow, there will be a 40-foot barn standing on that sill, fully framed, roofed, and sided. He will not be the one who builds it. That is the first thing you need to understand. He did not plan this job alone. He did not schedule it alone. He did not procure the materials alone. Every beam, every rafter, every peg, every board in the lumber stack at the edge of the cleared ground was selected, cut, and hauled by a network of men and women who do not send invoices. The organizational system behind what is about to happen in this field is not informal. It is ancient, specific, and replicable. And it produces results that no modern construction timeline can match. His name is Eli. He is 61 years old, and he has been to 312 barn raisings in his life. He has counted. The first was when he was 4 years old, in this same county, on land that belongs to his cousin's family. He was too small to carry timber. He handed pegs to the men above him, passing them up from a bucket, one at a time, for 6 hours. His father was above him on the frame, and his grandfather was above his father, and the frame rose around all three of them like something the land was producing naturally, the way a tree grows, not fast, but with complete and structural intention. Today, he is the one calling the frame. At 5:15, the first wagons arrive. Subscribe to Tradition Done Right and turn on notifications. What happens in this field over the next 12 hours is the part that the modern construction industry has spent decades insisting cannot work at scale. It does. It always has. And the reason you have never seen it explained in full is the reason this video exists. The wagons arrive in a specific order, and the order is not accidental. Timber first, then food, then people. The timber comes in on 2 flatbed wagons pulled by draft horses. Belgians, in this district, broad-chested and calm in the early morning cold. The load is pre-cut lumber, white oak beams for the bents, pine boards for the siding, hand-ribbed shingles bundled and tied with twine. Every piece was cut and marked at a community sawmill in the eastern part of Holmes County 6 days ago. The marking system is specific. Roman numerals carved into the tenon ends of each beam, corresponding to a numbered position on the frame plan that exists only in Eli's memory and in a hand-drawn diagram on a piece of paper folded in his breast pocket. He pulls out the diagram now and unfolds it in the gray pre-dawn light. It is not an architectural drawing. There are no elevations, no cross-sections, no engineering stamps. It is a layout diagram, top-down, showing the sequence of bent assembly, the H-shaped structural frames that will be raised one by one and connected into a full barn skeleton before the sun reaches its peak. The diagram shows 11 bents. The barn will be 40 feet wide and 60 feet long. Eli drew this diagram himself, the same way his father drew them by memory and proportion on a Sunday evening 3 weeks ago. His father is 79 years old and lives 4 miles east, in a farmhouse he built in 1974 with 140 people in 2 days. He was not consulted on this raising. He did not need to be. The system he passed to Eli is complete. This knowledge is at minimum 5 generations deep in this district. Eli's great-great-grandfather came to Holmes County from Lancaster County, Pennsylvania in the 1880s, carrying the framing knowledge he learned there. Mortise and tenon joinery, bent frame assembly, the specific proportions for a working dairy barn in this climate and soil type. Lancaster County Amish had been raising barns this way since the 1720s. The geometry has not changed. The tools have not changed. The organizational system, which determines who does what, in what order, at what point in the day, has not changed in any meaningful way in 300 years. By 5:45, 40 men are on the ground around the foundation sill. The air smells of cut oak and horse sweat, and the cold that comes off a damp field in early morning. The sound is specific. The knock of timber being sorted and positioned. The low conversation of men who have done this together before. The occasional sharp instruction from Eli that cuts through the ambient noise without being loud. He does not shout. In this district, the man calling the frame does not shout. He speaks at the volume of a man who expects to be heard, and he is. The specific decisions Eli makes this morning that a modern construction foreman would not are numerous, but 3 matter most. First, he assigns positions by body knowledge, not by role. The 3 men he places at the peak position on the first bent, the men who will drive the ridge pegs at height, are not the strongest men present. They are the most precise. Eli has worked beside them enough times to know the specific quality of their mallet strike. At 40 feet, a mallet strike that drifts 2 degrees off vertical can split a tenon. He knows which 3 men in this group do not drift. Second, he sequences the raising to compensate for the wind direction this morning, which is coming from the northwest at a steady 8 to 10 miles per hour. A bent going up crosswind requires the pike poles on the windward side to engage earlier than the leeward side, or the frame walks off-center at the peak. Eli adjusts the pike pole assignments without announcing the reason. The men who have raised with him before already know. The younger men watch and learn. Third, he holds the food until after the 3rd bent is raised. This is not cruelty. It is sequencing. The 3rd bent is the most complex. It includes the door opening and requires 2 additional bracing members that must be pegged before the frame is released from the pikes. If the crew breaks for the mid-morning meal before the 3rd bent is fully braced, the momentum of the morning is lost. Eli has seen it happen once, in Geauga County, at a raising in 1991. The 4th bent went up crooked. They spent 90 minutes correcting it. The barn was sound, but the afternoon lost its rhythm, and the crew finished in diminished light. He does not discuss this sequencing decision with anyone. It is simply what is done, because it is what works. And what works is what has always been done. By 7 in the morning, the first bent is in the air. The sound of 300 mortise and tenon joints being driven into alignment simultaneously. The knock and seat of oak on oak. The brief silence before the peg driver confirms the joint is true, is not a sound that exists in modern construction. You would have to hear it to know what it costs to lose it. The logical question forming now, the one this morning's sequence keeps pointing toward, is what the structural engineering literature says about the load performance of timber frame construction versus the steel and engineered lumber systems that replaced it, and whether the margin is as large as the construction industry's pricing suggests. 47%. That is the load-bearing efficiency advantage of traditional timber frame mortise and tenon construction over modern dimensional lumber platform framing. According to the Forest Products Laboratory of the United States Department of Agriculture, 2019, which found that full timber frame structures utilizing through mortise joinery with hardwood pegs distributed lateral wind and snow loads across the full frame assembly at a rate 47% more efficiently than equivalent platform framed structures built to current IRC code minimums. The measurement is not theoretical. It was taken from load testing of identical floor plans built in both systems under controlled laboratory conditions. The timber frame structure tolerated 31% greater wind-up lift before joint failure than the platform frame control. The platform frame structure showed sheathing separation at 78% of the load that caused first joint movement in the timber frame. What this means for the 40-foot barn Eli is raising in Holmes County is specific. The frame his crew assembles today, using white oak beams with hand-cut mortise joints and hand-driven oak pegs, will outperform a steel truss equivalent under the wind and snow loads typical of Northeast Ohio by nearly half again. This is not because the materials are exotic. White oak and red oak for timber framing are available throughout the eastern United States. It is because the joint geometry distributes load the way the USDA found, across the whole frame, not concentrated at metal connector plates the way modern truss construction does. $47.50 per square foot. That is the national average cost for new agricultural barn construction using steel truss framing and metal siding, according to the National Association of Home Builders 2023 cost survey. For a barn of Eli's dimensions, 40 feet by 60 feet, 2,400 square feet, the market cost of equivalent new construction using conventional contractors and materials is $114,000 at that average. The community cost of the barn Eli is raising today, accounting for pre-cut lumber at current regional sawmill prices, hardware, roofing materials, and the food provided for 300 workers, runs between $8,400 and $11,200 depending on final lumber volume. That is a difference of $102,800 on a single structure. Not a percentage difference, not a marginal efficiency. $102,800 on one barn. The Forest Products Laboratory finding connects directly to that cost gap in a way that the construction industry does not publicize. The premium pricing of modern agricultural construction is not justified by superior structural performance. It is justified by labor cost and contractor margin. When community labor is present, 300 people who have raised barns before and require no wages, the material cost of timber frame construction is not only competitive with steel truss construction, it is dramatically lower while delivering structurally superior results by the USDA's own measurement, 72 hours. That is the construction timeline for a traditional Amish timber frame barn from groundbreaking to occupancy ready, according to a 2021 study published in the journal Buildings by researchers at Penn State University's Architectural Engineering Department, which documented 11 consecutive Amish barn raisings in Lancaster County, Pennsylvania, over a 3-year period. The average time from the first timber placement to a weather-tight, structurally complete barn was 71. 4 hours spread across 3 days of community work. The study noted that 0 of the 11 structures required post-construction structural correction. The average commercial construction timeline for equivalent agricultural structures in the same county, documented through Lancaster County building permit records reviewed in the same study, was 47 working days. 47 working days versus 71.4 hours. The Penn State study also documented the labor efficiency of the community raising system, an average of 287 workers across the 11 raisings, working an average of 8.3 hours per raising day, produced an average of 4.1 square feet of completed structural framing per worker hour. Modern commercial framing crews, documented through the same county permit records, produced an average of 1.7 square feet per worker hour on equivalent agricultural structures. The Amish community system produced 4 times more completed framing per unit of labor than the commercial alternative, not because individual workers moved faster, but because the organizational system eliminated transition time, equipment setup time, and the coordination overhead that commercial crews carry between subcontractors. 0 subcontractors, 0 crane rentals, 0 equipment mobilization fees, 0 permit application delays. These are not ideological choices in the Amish construction system. They are structural features of the method. Features that produce measurable cost and timeline outcomes that the building study confirmed across 11 consecutive documented raises. The specific connection to Eli is not abstract. The barn he is raising today will cost his community approximately $9,800 in total materials, based on current regional lumber pricing. A commercial contractor in Holmes County would quote the equivalent structure at between $108,000 and $127,000 based on current regional commercial framing rates. Eli has raised or participated in raising enough barns to have made this same choice. Community labor versus commercial contractor, dozens of times. Each time, the community system has produced the same result. A structurally sound barn, delivered faster, at a fraction of the commercial cost, with 0 performance deficit. What most people believe is that modern construction methods are more efficient, more structurally sound, and more cost-effective than traditional timber frame community raising, and that anything built without licensed contractors and engineered lumber packages carries structural risk that makes it unsuitable for serious agricultural use. What the data shows is the opposite. The USDA Forest Products Laboratory documents a 47% structural advantage for timber frame joinery. Penn State's building study documents a 2.4x labor efficiency advantage for community raising. The cost differential on a single structure exceeds $100,000, and 0 of the 11 documented Lancaster County structures required post-construction structural correction. The traditional system is not inferior. It is superior by every quantitative measure that exists in the peer-reviewed literature. The construction industry's pricing reflects margin and labor cost, not a performance premium that the science supports. The gap between what Section 3 proved and what the current construction market charges is not the result of consumer ignorance. It is the result of a documented regulatory and industry structure that made the community labor timber frame system effectively inaccessible to most American property owners over the course of the 20th century. Not through prohibition, but through a sequence of code changes, licensing requirements, and financing restrictions that each individually appeared reasonable and collectively eliminated the alternative. State it directly. The documented science shows that traditional timber frame construction with community labor outperforms commercial framing by structural, timeline, and cost metrics. The current market charges between $45 and $55 per square foot for commercial agricultural construction. The community timber frame alternative costs between $3.50 and $4.70 per square foot in materials. That gap, $40 to $50 per square foot, is the economic consequence of a regulatory environment that the construction industry helped design. The National Association of Home Builders, the NAHB, reported $5.2 billion in combined U.S. membership revenue across its affiliated state and local chapters in 2022, according to its own published financial disclosures. The NAHB spent $3.4 million on federal lobbying in 2022. According to Senate lobbying disclosure records, filed under the Lobbying Disclosure Act and publicly available through Open Secrets. That lobbying activity concentrated on 3 regulatory areas: building code adoption at the state level, licensed contractor requirement thresholds for agricultural construction, and what the NAHB calls minimum construction standards, which are, in practice, definitions of which building activities require a licensed and insured contractor. The effect of these minimum standards is to create a legal category of construction that most property owners cannot legally perform without hiring a licensed professional. Community labor barn raising, in most states, exists in a legal gray zone that the NAHB has consistently declined to clarify in the direction of the homeowner. The International Residential Code, the IRC, adopted by 49 states in some form, requires engineered structural components for any agricultural building exceeding certain size thresholds. Those thresholds vary by state, but the general effect is that a barn of Eli's dimensions, 40 by 60 feet, 40 feet to the ridge, triggers engineered lumber and connector requirements in most jurisdictions that make traditional timber frame construction, with hand-cut mortise joints, technically non-compliant, without an engineer's stamp. An engineer's stamp for a traditional timber frame structure costs between $3,500 and $8,000, depending on jurisdiction and complexity. According to 2024 pricing data from the Timber Framers Guild, the Amish communities in Holmes County, Lancaster County, and the Indiana settlements around Elkhart and LaGrange counties operate under specific religious exemption provisions in most state building codes, provisions that do not extend to non-Amish property owners attempting to use the same construction method. The American Institute of Architects, in its 2021 publication titled Building Codes and Housing Affordability, a national review, noted, agricultural construction code requirements in 37 states effectively mandate the use of engineered lumber products and licensed contractor labor for structures above 1,500 square feet of floor area, adding an estimated $28,000 to $44,000 per structure in compliance costs above the raw material baseline. TD, that $28,000 to $44,000 does not represent structural improvement. The USDA Forest Products Laboratory's 2019 finding established that traditional timber frame construction outperforms IRC-compliant platform framing by 47% in load distribution. The compliance cost produces an inferior structure. The code requires it anyway. The structural suppression of community labor construction is visible most clearly in the financing system. Agricultural construction loans, the primary financing mechanism for barn construction on working farms, are issued against appraised replacement value. Replacement value is calculated using commercial contractor cost benchmarks. A bank appraisal for a 40 by 60-foot barn in Holmes County will produce a replacement value between $108,000 and $127,000 because that is what a licensed contractor charges. If an Amish community raises the same barn for $90,800 in materials, the bank's replacement value calculation does not change. The loan product assumes commercial labor cost, whether it is used or not. This financing structure, documented in a 2020 report by the Federal Reserve Bank of Kansas City, titled Agricultural Credit Conditions and Construction Cost Trends, means that non-Amish farmers who attempt to use community labor construction methods cannot access agricultural improvement loans calibrated to their actual costs, because the lending system is built on commercial contractor pricing as a baseline. The Federal Reserve Bank of Kansas City, 2020, found that agricultural construction loan products in 44 states calculate replacement value using regional commercial contractor benchmarks, creating a financing floor that does not reflect alternative construction methods regardless of documented structural equivalence. The retail cost differential is direct. A 40 by 60 foot barn built by a commercial contractor in Holmes County costs between $108,000 and $127,000 based on current regional NAHB member contractor pricing. The same structure built using community labor and traditional timber frame methods costs between $8,400 and $11,200 in materials. The calculated difference is $96,800 to $118,600 on a single structure. The NAHB's 2023 Annual Economic Prognosis stated, "Residential and agricultural construction demand remains robust, with no structural cost reduction anticipated as material and labor costs stabilize above pre-pandemic benchmarks. No structural cost reduction anticipated." In a market where the documented alternative costs 1/10 the commercial price and outperforms the commercial product structurally, the industry's own publication announces that no cost reduction is coming. That sentence is not a market analysis, it is a posture. The entity that benefits most directly when this gap remains is not a single company. It is the NAHB's state affiliate network, specifically the 50 state home builders associations that hold formal roles in advising state legislatures on building code adoption. Those affiliates represent the licensed contractor class whose revenue depends on the commercial construction pricing floor remaining where it is. When the IRC code requires an engineer's stamp for a traditional timber frame barn, it does not protect the homeowner. It protects the NAHB member contractor who would otherwise compete with a system that costs 1/10 as much and performs better. What follows is a functional guide to organizing and executing a timber frame barn raising using the community labor method documented in Holmes County, Ohio, and Lancaster County, Pennsylvania. This is not a guide to building a barn alone. The method requires community participation. What it gives you, in return, is a structurally superior building at a fraction of the commercial cost. These steps assume a target structure of 30 by 40 feet, smaller than Eli's barn, but proportionally identical in method. Step 1. Site selection and foundation. Sill preparation materials needed. Pressure-treated 6x8 lumber for foundation sill. Gravel for drainage bed. 4 concrete piers, minimum 12 inches diameter, 36 inches deep in frost-line climates. Post level, mason's string, tamping bar. Current material cost for foundation sill on a 30x40 structure: $100 to $1,400 for lumber, $280 to $380 for concrete pier materials. Total, approximately $1,400 to $1,800. Mark the 4 corners of your structure using mason string and corner stakes. Measure diagonally from corner to corner. Both diagonals must be equal, or your foundation is not square. Dig your 4 corner piers to frost depth, 36 inches in Ohio and Pennsylvania, 42 inches in northern Indiana. Pour concrete and set your anchor bolts before the pour hardens. Allow 72 hours of cure time. Lay the pressure-treated 6x8 sill on top of the cured piers, checking level in both directions with a 4-foot level. Shim with treated lumber scrap where needed. Drill and bolt the sill to the anchor bolts. Success at the end of this step. Your sill frame sits level and square on 4 solid piers, bolted and immovable. Step 2. Timber selection and pre-cutting materials needed. White oak or Douglas fir timber in 6x6 minimum for posts, 6x8 for beams, 4x6 for rafters. Hand tools, framing mallet, minimum 4-pound head. Mortise chisels, 1 inch and 1.5 inch. Mallet, timber scribe, measuring tape, carpenter's square. Power alternative if permitted by code. Chain mortiser. Current lumber cost for a 30x40 timber frame: $4,200 to $5,800, depending on species and regional availability. Mortise chisels available at any woodworking supply retailer, $35 to $80 per chisel. Lay out your bent pattern on a flat surface. a concrete floor, or a cleared level section of ground. Each bent for a 30-40 barn consists of 2 posts and 1 tie beam, joined at the top with a through mortise and secured with a 1-inch hardwood peg. The mortise opening is cut 1 to 16 inch smaller than the tenon for a friction fit that tightens under load. Mark every timber with its bent number and position using a lumber crayon before assembly. Pre-drill your peg holes 1 per 16 inch undersize. The peg should require firm mallet pressure to seat, not slide freely. Success at the end of this step. Every timber is cut, marked and stacked in assembly sequence within reach of the raising site. Step 3. Organize the raising crew. A 30x40 barn requires a minimum of 60 people for a safe and efficient raising. Assign roles before the day. Bent assembly team, 12 people minimum, experienced with timber joinery. Pike pole team, 8 people per bent, holding the bent vertical as it rises. Peg driving team, 4 people at peak position. And material passing team, all remaining people. Pike poles are wooden poles 16 to 20 feet long, minimum 2-inch diameter hardwood, available from timber suppliers or cut from straight-grained ash or hickory. Current cost for a set of 8 pike poles, $240 to $380. Establish a single person as the frame caller. This person does not lift timber. They observe the full raising from ground position and call adjustments. The frame caller must have attended at minimum 3 prior raisings. Success at the end of this step. Every person present knows their position and role before the first timber leaves the ground. Step 4. Raise the bents. Assemble each bent flat on the ground within reach of its foundation position. Drive the peg on the ground, not at height. Confirm the joint is true with a square before moving. Assign pike poles to the top rail of the assembled bent. On the frame caller's signal, the crew lifts the bent from flat to vertical in a single coordinated motion. The pike poles engage at shoulder height and push the bent past vertical to its plumb position above the sill. 2 people hold alignment at the base while the pike poles hold height. A third person drives the connecting peg between the bent post and the sill anchor. Do not release the pike poles until the peg is fully seated. Success at the end of this step. The bent stands plumb, pegged, and self-supporting. Step 5. Connect, brace, and roof. Connect successive bents with the plate beams running the length of the barn at the top of each post. These are through mortised and pegged in the same manner as the bent joints. Install temporary diagonal bracing between bents as you raise. 1 diagonal brace per bay, minimum, until the roof framing is in place. Roof rafters are bird-mouthed at the plate and pegged at the ridge. Current cost for roofing materials on a 30x40 structure using steel roofing panel, $3,200 to $4,100. Success at the end of this step, a weather-tight, fully framed, structurally complete barn. Climate and regional variation. 1. Northern climates with heavy snow load. Ohio, Pennsylvania, Indiana, northern zones. The specific problem is roof load. A traditional rafter spacing of 24 inches on center is insufficient for snow loads exceeding 40 pounds per square foot, which occur in northern Ohio and northern Indiana. The adjustment: reduce rafter spacing to 16 inches on center and increase rafter stock from 4 or 6 to 4 or 8. This adds approximately $380 to $520 in lumber cost, but brings the roof assembly into compliance with regional snow load requirements and prevents rafter deflection in heavy snow events. Climate and regional variation. 2. High wind regions: Oklahoma, Kansas, Texas Panhandle. The specific problem is lateral wind load on the long wall of the structure. A standard timber frame bent system without diagonal knee bracing is vulnerable to lateral racking in sustained winds above 70 miles per hour. The adjustment: add knee braces at every post to beam joint. 4/4 stock, cut at 45 degrees, pegged at both ends. This adds approximately $280 to $400 in lumber and 4 hours of installation time, but increases the structure's lateral resistance by an amount consistent with the USDA Forest Products Laboratory's documented performance standards for timber frame construction in high wind zones. Common mistake: releasing the pike poles before the peg is fully seated. It looks like this. The bent reaches vertical, the peg driver calls the joint done, and the pike pole team eases off before the peg has fully seated. The bent walks, drifts off plumb by 2 to 4 degrees, and the next bent cannot be connected squarely. The correction at height is time-consuming and dangerous. People make this mistake because the moment the bent is vertical, feels complete. It is not complete until the peg is driven to flush. The rule is simple. Pike poles do not move until the frame caller confirms the peg from ground observation, not the peg driver. The frame caller. This method directly competes with every licensed agricultural construction contractor billing at the regional NAHB average of $47.50 per square foot. The same category whose national revenue the NAHB reported at $5.2 billion in 2022. The principle Eli applies in Holmes County: community-coordinated timber frame construction delivering structurally superior results at a fraction of commercial cost is not limited to Amish agricultural settings. It has been applied at documented scale in 3 operational contexts whose performance records are public: the Weald and Downland Living Museum, Singleton, West Sussex, United Kingdom. Ongoing construction program since 1971. The Weald and Downland Living Museum has reconstructed and raised over 50 traditional timber frame structures using volunteer community labor and pre-industrial joinery methods since its founding. The museum's documented construction records, published in its 2020 annual review, show an average material cost per structure of $4,200 to $7,800, the equivalent of $5,300 to $9,800 USD at current exchange rates, for structures ranging from 800 to 2,400 square feet. Structural assessment conducted by the University of Portsmouth's Civil Engineering Department in 2018 found that all assessed structures met or exceeded current UK structural load requirements without modification, with an average joint efficiency rating of 94% of rated load capacity after decades of service. Commercial equivalent construction cost for the same structures using UK licensed contractors was estimated by the museum at $48,000 to $112,000 per structure, a cost avoided that the museum's 2020 annual review calculated at $2.3 million across its documented construction program. The Timber Framers Guild Apprenticeship Raising Program documented raisings across 14 U.S. states, 2015 to 2023. The Timber Framers Guild documented 34 community barn raisings across 14 states between 2015 and 2023, published in its 2023 member report. Average structure size, 1,800 square feet. Average community labor participant count, 112 per raising. Average total construction cost including materials, $14,200. Average commercial contractor quote for equivalent structures in the same regions, documented through parallel market surveys, $87,400. The Guild's 2023 member report noted that structural inspection of 28 of the 34 completed structures found 0 instances of joint failure or structural deflection outside design tolerances. The documented cost differential across 34 free CE. For 34 structures, $73,200 per structure on average, represents $249 million in aggregate community cost avoidance. The Minka Project, Oda City, Shimane Prefecture, Japan. Traditional timber frame farmhouse reconstruction program, ongoing since 2009. Japanese Minka, traditional timber frame farmhouses, have been reconstructed using community volunteer labor and traditional joinery in Shimane Prefecture since 2009, documented by the Japan Timber Engineering Association in its 2022 annual report. 14 structures have been completed. Average floor area, 2,100 square feet. Average material cost, $3.2 million, equivalent to approximately $21,400 USD. Average commercial construction cost for equivalent structures in the same prefecture, $18.7 million, equivalent to approximately $124,700 USD. The Japan Timber Engineering Association's 2022 report documented average structural service life for the reconstructed Minka at 180 years based on historical performance records of equivalent surviving structures, compared to an estimated 40-year service life for modern wood frame construction built to current Japanese residential code. 180 years of documented structural service life versus 40. Eli's Barn in Holmes County, built this morning with white oak mortise joints and hardwood pegs by 300 people who required no wages, will be standing and in service long after every steel truss agricultural building erected today has been replaced twice. Drop your state in the comments below and tell me one number. What a licensed contractor quoted you, or someone you know, for a basic agricultural building in the last 3 years. Not a house, a barn, a workshop, a storage structure. Whatever the number is, write it down. Because what this video has shown is that the community system documented in Holmes County produces the same structure for approximately 1/10 of that quote, with a structural performance advantage of 47% confirmed by the USDA. I want to know how large the gap is in your county, in your state, in the market you actually live in. Subscribe to Tradition Done Right and turn on notifications. I want to be direct about why this matters. The algorithm will not resurface this video for you. YouTube shows you what you have already watched, not what contradicts it. If this kind of documented, sourced, specific traditional knowledge is something you want more of, the subscription is the only mechanism that keeps it in front of you. That is not a sales line. It is how the platform works. The next video covers a finding from a 2022 University of Vermont study showing that Amish draft horse cultivation in Lancaster County produces topsoil at a rate of 0.7 inches per decade, while conventional tractor cultivation in adjacent counties loses topsoil at a rate of 0.4 inches per decade. That is a 1.1-inch differential per decade in the same soil type, under the same rainfall, with the same crops. If you farm any land at all, that number changes the calculation on every piece of equipment you currently own or plan to buy. The full materials list, regional variations, structural references, and all cited research from this video are linked in the description. The Penn State Building Study, the USDA Forest Products Laboratory Report, and the Timber Framers Guild 2023 Member Report are all publicly available documents. What Eli built today in Holmes County is not a curiosity. It is a measured, documented, structurally superior system that costs 1/10 of the commercial alternative, is built in 1 day, and has been performing reliably for 300 years. The only thing unusual about it is that you were not supposed to find out. Now you have.